We have already discussed knapsack problem. Now the next problem what today we will discuss 0 1 knapsack problem. Okay, 0 1 knapsack problem is very similar to the knapsack problem. Like the statement of the knapsack problem what you have studied already. N number of objects given that. What is the problem? Given that n number of objects, okay, and then n positive weights, w1 w2 so on wn, n positive profits P1, P2 so on Pn, and m positive number m is knapsack capacity. Okay. Okay, so here in the case of knapsack problem, in 0 1 knapsack problem also there are n number of objects, n positive weights associated with the n objects, and the profits also associated with, means w1 is the object of weight of the first object, p1 is the profit of the first object, w2 is the weight of second object, and p2 is the profit of second object. In general, wi is associated with the ith object, which is the weight of ith object, and pi is the profit of ith object. And in addition with weight vector and the profit vector, one positive number m is given, which is the knapsack capacity. This is given. Now what is our objective is simply maximize summation pi xi subject to summation wi xi less than or equal to m, where xi equal to 0 1 for I is greater than or equal to 1, less than or equal to n. Okay, so see in the knapsack problem, and the 0 1 knapsack, this is the objective of 0 1 knapsack problem, maximize the profit earned, and the feasibility condition is that of course the knapsack capacity should not exceed from m. And now here the restriction is that the value of each object is either 0 or 1, means just it can take the value either 0 or 1. In the case of simple knapsack or fractional knapsack, here there is a difference. In the previous knapsack what we have studied, or simple knapsack, called sometimes it is called fractional knapsack, where it is allowed to take fraction of ith object, like xi can be in between 0 and 1. Okay, but here in the case of 0 1 knapsack, clearly note down that the every other statement is same, objective is same, but there is a restriction. Restriction is that either you have to include the object or exclude the object. Fractions are not allowed, and the corresponding problem is called 0 1 knapsack problem. If the problem is knapsack problem, then it means it is a simple knapsack where the fractions are allowed. When the fractions are not allowed, then it is clearly mentioned that this problem is 0 1 knapsack problem. Okay, so here everything is same, that the n number of objects corresponding to n objects, the weights and profits are associated. One knapsack is given whose capacity is m. Our objective is to maximize the profit, means to fill the bag in such a way that the maximum profit is achieved, and the condition is that the knapsack capacity should not exceed from the knapsack capacity, and either you have to include the whole object or you exclude the object. Okay, and the value of the I is, this is applied for all the objects. Okay, so now this problem we are going to solve using backtracking algorithm. There are a number of other ways to solve 0-1 knapsack problem. First, I will see this problem cannot be solved by greedy method, what we have used to solve fractional knapsack or simple knapsack problem. First, I will explain that simple greedy technique will not work to solve 0-1 knapsack problem. So for that, I have taken two examples here to explain that the greedy approach will not work to solve 0-1 knapsack problem. Okay, so here this is the first example. I have taken the number of objects is 3, the knapsack capacity is 50, and the profit vector is this, weight vector is this. So first we compute what profit per unit weight, that the profit per unit weight is 654. Okay, this 60 divided by 10 6, 100 divided by 20 is 5, 120 divided by 34. Now you can see that profit vector and weight vectors here are arranged according to the decreasing order of profit per unit weight, as we do in the case of solving simple knapsack problem with greedy technique. Okay, if we apply the same greedy technique to solve 0-1 knapsack problem, then simply our solution vector is here, x is this object weight is 10 and the knapsack capacity is 50. So we can include it, okay, as a whole, and simply just the another, so the knapsack capacity is 10, so the remaining capacity is what, 30. Or if you feel comfortable here with the table, like P is 1, 2, 3, P is 60, 100 and 120, and weight is 10, 20, 30, and then profit per unit weight is 654. Okay, so see, if you arrange that, then the first we consider this weight. Okay, so x is what, 1, and the remaining capacity, its weight is 10, so the remaining capacity of the knapsack is what, 40. Okay, now the next we consider this one, so the whole object to be considered 40, and thus its weight is 20, so the remaining capacity is 40 minus 20 is 20. This is the remaining capacity. Okay, and because fractions are not allowed, so we will not consider the third object. So our solution vector is 1 1 0. Here the solution vector is 1 1 0. If we consider the total profit earned with this, the total profit is simply 60 plus 100 equal to 160. Carefully see, if we solve the same if we apply the same greedy technique for this example or for this instance to solve 0-1 knapsack problem, then fractions are not allowed. So what we do, we arrange the profit vector and weight vector according to the decreasing order of profit per unit weight, and simply we consider one by one. So this first object can be considered fully, the second object can be considered fully, as when we its weight is 30, so we cannot include this object. So here this is 0, as fractions are not allowed in 0 1 knapsack problem. Okay, so here the total profit is 160. Now you can see from this there is a one more solution vector. This is the first solution. There is another solution vector is what? 0 1 1 in this way, where the here you can see that the total profit is 160. If you consider the total weight or the filled knapsack is what? 10 plus 20 is 30. Okay. X is here. X is 1, 1 and 0. Total weight added into the knapsack is what? 10 plus 20, 30, and total profit is 160. If there is another solution for this same problem, 0 1 1, and here the total profit, as you can see that the total profit is what? Total profit is, you add 0, that is 100 plus 120 equal to 220, because I have included this object, but the first object is excluded, the second object is included, and third object, so 220. So the first thing, this is the example that you can differentiate that with the greedy approach 0 1 knapsack problem cannot be solved. Okay, just here I have taken the another example, just example 2. Like the profit vector is this, weight vector is this, and if you consider the profit per unit weight, so profit per unit weight is 9, 8 and 6, 4. Okay, so see, just I have taken the profit and weight vector in such a way that the profit and weight vectors are arranged according to the decreasing order of profit per unit weight, that is P1 upon W1 is greater than P2 upon W2 is greater than, and so on. Okay, suppose again if we are going to solve this 0 1 knapsack problem using greedy technique, so what is the solution vector according to our, just here the knapsack capacity is 50. So the first object weight is 6. It can be included, okay, the fully, and then next object is 10. So it can be included, okay. So 1 and 1. So the total is 16, okay. And then here this is also included. The total capacity is 16 plus 12, that is what? 28. 16 plus 12 is what? 28. Okay, 28. Now the knapsack capacity is 50. So now the 30 cannot be added, because the 28 minus 50 minus 28 is 22. So the 30, this weight cannot be added. So simply this is the solution vector generated using greedy approach. Now see its total profit. If this is the solution vector, then check it, what is its total profit? Total profit is what? 54 plus 80 plus 72. That is, the total profit is 206. Here the total profit is 206 if we solve the problem using greedy method, where I am applying the greedy method but fractions are not allowed. Okay, so again see, from this profit and weight vector you can check that if we consider x equal to another solution can be like 10, 12 and 30. You can consider 10, 12, 22 and 30 is not, just another solution vector is can be 6, sorry, just here 6, 12, 18 and 30, 48. Okay, so one is 1, 0, 1, 1. This can be the another solution, because 6 plus 12 is 18, 18 plus 30, 30 and 18 is 48. Okay, so it is not exceeding from 50. So this is the another solution vector for the same problem, but I have not generated only the hit and trial. I have written this solution vector. Okay, I have not applied any algorithm. Okay, total profit for this case is what? 1, that is 54, and the second is excluded, the third is 72, and the fourth is 30. What is its total profit achieved is and M is 50. M is 50. So here 30 plus 12 plus 6 is not exceeding from, this is a 40, this is 48. So here the 54, 72 and 120. This is what? 120. Okay. 120. Now just 6 and 246. Okay, so here the one solution vector whose see this, for this solution vector the profit is greater than the solution vector which is generated through greedy technique. There can be the more one other solution like x equal to what you consider 6, 10 and 30, 40, 46. So we can consider like 1, 1, 0, 1. This is the another solution. So for this solution the total profit TP, total profit is what? 1 is 54 plus 80 plus 120. Okay, then see 4 and then 254. Okay, 4, 254. Now see, so 1101 is the optimal solution that is giving the maximum profit for this problem. Okay, so first understand ki what is 01 knapsack problem. 01 knapsack problem, the only difference between the 01 knapsack problem and the simple knapsack, in the simple knapsack fractions of the objects are allowed. Here we consider the raw material like rice or just the value of the object is not going to change. But in the case of 01 knapsack problem, if there are objects like marble pieces, here if we break the marble pieces then there is no use of that particular object. That's why just in the 01 knapsack problem our condition is either we have to consider the weight whole object either to include or exclude. Okay, and this problem is more difficult as compared to the simple knapsack where the fractions are allowed. So the fractional where the fractions are allowed, this problem can be solved easily, as we saw earlier that we arrange the profit and weight vector according to the decreasing order of profit per unit weight and we consider the weight accordingly. But here see, just the same approach cannot be used to solve the 01 knapsack problem. So there are number of other approaches. In your course there is a backtracking algorithm to solve this problem. The next we study the branch and bound method to solve the same 01 knapsack problem because the complexity is exponential here, and dynamic programming is also used to solve the same 01 knapsack problem. Okay, so there are two examples. One more thing you can note down that in the case of greedy method, if you solve in the first example, see, if you are applying the greedy technique, okay, greedy technique means if you are solving the fractional knapsack. In the first example, see, in the first example, if suppose fractions are allowed, if the fractions are allowed, then what will be the solution for this? If the fractions are allowed, simply the remaining capacity is 20. So here just we take the last like 20 by 30, that is 2 by 3 or 2/3 of the last object. Okay, so see, just here what will be the total weight? In the first case, what will be the total weight? total weight is what? Total weight is 50 always. Means when fractions are allowed, then knapsack will always be full, because as soon as the capacity is remain, we consider the fractions of the last object. But this is not the case in 0-1 knapsack problem. Here the knapsack may or may not be full. Like this is the example where the knapsack is full. Like say this is the optimal solution and our total weight is also 50. But if you consider this example here, this is our optimal solution. This is our optimal solution 1101. In the second case, our optimal solution is x1101. If we consider this particular solution, then the total weight is what? 6 plus 10 plus 30. That is what? 46. And the knapsack capacity is 50. So always remember that in case of fractional knapsack, when fractions are allowed, then knapsack will always be full. But when in the case of 0-1 knapsack problem, where there is a condition or restriction that either we have to include or exclude the whole object, knapsack may or may not be full. This in the case of first example. See, in the case of first example, what I have considered, the optimal solution is this, and the total weight is 50 and the knapsack capacity is also 50. But here the knapsack capacity is 50 and the optimal solution is 1101, whose the total profit is 254. But the knapsack is not full. Okay. The second is if you are going to take the profit. So if you are solving the problem using greedy technique and allowing the fraction, then you always get the maximum profit, which is not in the case of 0-1 knapsack problem. You can check it. Like say suppose this is the problem, and if we solve the greedy method, then the profit is 160. Okay. If the fractions are allowed, then our solution vector in the case of first example, our solution vector is what? Solution vector is 1, 1 and 2 by 3. This is the solution vector 1, 1, 2 by 3. So if you consider the profit, total profit achieved in this case, total profit achieved is 60 plus 120 plus 2/3 into 100. 60 is the profit of the first object, 100 is the profit of the second object, and 2/3 of the profit of the third object. Okay, 120. Okay, so 40. So 60 plus 100 plus 80. That is what? This is 240. And here, see, if we solve the 0-1 knapsack, by allowing the 0 and 1, the maximum profit is 220. Okay. So what is the conclusion here? That if we fractions are allowed, then knapsack will always be full and the profit achieved is maximum. And in the case of 0-1 knapsack problem, profit achieved is less than or equal to the profit achieved through the fractional knapsack, what we solve using greedy technique. Okay, so this is the description of the problem. What is 0-1 knapsack problem? And clearly you can give the example that greedy approach will not work to solve 0-1 knapsack problem. So clearly note down these two examples to explain that the greedy approach will not work for solving 0-1 knapsack problem. So now we go for other technique. Here the next I will discuss backtracking algorithm to solve 0-1 knapsack problem. Okay.